Alright, so I'm just going to give you a second on the answer page. This is also on the ones that I've been posting if you go to page 55. Okay, but anyways, here's the answer. Okay, answers for number 84 through 92. Right, so I'll come back periodically to check it. Okay, so let's start with 84. And I think we went over a couple of these in class already. Okay, so 84, I believe this one we already did in class. Okay, this one would not be a good test question, quiz question, because it relies on which of the following statements, right? Which means that you will need to see your answers, right? So I can't actually use this because on the test or quiz, I will take out all the answers. Okay, but we went over 84 in class already. Um, 80, 80, oh, what happened to 85? Sorry, 85. Oh, 85 is not here. Yeah, we went over 85 in class already, and if you need the answers, go to the beginning of the video. You'll see the answers there, or every now and then I'll switch back to the answer page, and you can see 85. We already did this one, I believe. Yeah, this is the one that, yeah, this is the last one that we did. And then 86, this one we started this. We, let's see, if the first derivative is greater than 0, and the second derivative is less than 0, meaning it's concave down, right? Which of the following could be a table, right? So we looked at this one, we said that it couldn't be B because if you look at all the values, a negative 1 is 4, 0 is 4, 1 is 4. That means that a negative 1, you got a point right there, 0, you get a point right there, and 1, you get a point right there, which means that this function is constant, which means that your slope is not increasing. Okay, we need it to kind of look like this. Oh, so it needs to be increasing. Okay, so it's not B, so we know that. And I think we also ruled out that it was not A. Okay, and because it's going down, so negative 1 is 4, 0 is 3, 1 is like 1, way down here, right? And we know that the slope should be increasing from this first part right here, right? So that means that we have eliminated A and B. Okay, now, so if you were in a rush and you only have about 2.9 minutes or about 3 minutes each, okay, you can definitely choose C, D, or E. But if you look at C, okay, so I so let me just kind of get this kind of started, right? So at negative 1, at 0, and at 1. So if at negative 1 you're at, let's see, this goes all the way to, and let me just move this down just a bit. Okay. So if at negative 1 you're at 4, 1, 2, 3, 4, 5, 6, 7. All right, so let's just say at negative 1 you're at 4. At 0, right here, we're on chart C, you're at 5. And at 1, you're at 6. Okay, so this does increase, and it does work right here. So check. But this is not a concave down because it's too steady, right? It's consistently rising at the same rate, and we want the slope so that the second derivative will actually be 0 because it's just consistent. But we want the second derivative to be negative, which is concave down. And right here, this is consistently growing at 1. So then we know that it cannot be C in this case. Okay. Let's move this aside. Okay, so it's not C. D, I'll use a different color. Right. D, if we look at that, Negative 1 is 4. 0 is 5. And then 1 is 7. You can see that um, the derivative is greater than 0 because it is increasing. Okay, but you can see how that it actually, goes from 4 to 5. It goes up by 1, right? And then from 5 to 7, it increases. Right? It actually doesn't go up by 1, it goes up by 2. So it's actually a little bit more steeper. And in this case, your rate of change, or the rate of change of the rate of change, or the second derivative here, that's actually increasing. It's positive. This will actually mean, if that was a picture, that would mean that it's a concave up, because it's curving up. And you can see from my drawing, it's curving up, which means that this is wrong because we want it to be curving down, because we want it to be concave down, or we want the second derivative to be less than 0. So this was close, but it's not. So we're going to go ahead and eliminate that as well. Okay, so it's not it's not D. Although that was, was fine. So it has to be E. And if we look at E, we'll put in green. Negative 1 is 4. 0 is 6. And then 1 is 7. Right? So it goes up by 2. Okay, so it's increasing. So that works here. But then from 6 to 7, it's only going up by 1. It's still increasing, okay, but it's slowing down. And you can see that if I'm kind of drawing this picture here, it's kind of curving down, which is a concave down. It's a concavity of a downwards motion. So that right here, I would say, fits this need also, and that would be answer choice E. If you look back at your answer, oh, that was number 86. Oh, too much. 86 right here. Answer is E. Okay. Okay. I kind of squish a couple of them together. So this right here. How many relative extremas does it have? Oh, this one, I'm going to go ahead and excuse my messy desktop. I'm going to get a calculator to help me, because this is calculator allowed, or calculator um, would be fine. So, if I use a calculator and I graph this function, or put this function in, this is from my previous. All right, so this is the, the 87 says let f be the function with the first derivative given by this function here. Okay, how many relative extremas does it have on the open interval? So all we really need to do is look at the derivative, or the first derivative right here, which is given. And luckily we have a calculator allowed option. So we're going to go ahead and type in, this is going to be 3 minus 2x minus x squared. Close that off, and then it's going to be times sine. You don't have to put times, but 2x minus 3. Okay, and then I'm going to go ahead and zoom. And this one I'm going to be a little bit, let's do zoom 6 just to see how it looks like. Okay, it's going to look like that. Okay, but we are only interested in the interval from -4 to 2. So I'm going to go back in my calculator, and once you get pretty good, you can do this fairly fast. My x minimum, the lowest, is going to be -4, and my x maximum, the highest, is going to be 2. I'm going to go ahead and leave the rest of it alone. I'm going to leave the y minimum at -10 and the y max at 10, and I'm just going to hit graph. You'll see that every time it hits the 0, that's where it has a slope of a 0, which means that it could be a relative max or a relative min. Okay, so it looks like it crosses 0 once right there, where my little cursor is. There, you can see it bouncing around, I think. Once right there, 2. So 1, 2, 3 right here, 4, and 5. Okay, and 5 is a choice, so that's possible. But you know what? Right there, I'm going to zoom in on it just to see, because it looks like it might be a little bit over, or it might look like it bounces. It looks like it doesn't bounce enough. So it looks like it actually goes through. So I'm going to zoom in right there. So I'm going to I'm going to hit zoom, zoom in, and we go to that spot right there at about -3. So it looks like it actually might go, because it looks like it's, some of it's cut off. So I'm going to go ahead and zoom in on it. So let's see. So it looks like 5, and oh, you see that? It actually goes a little bit above. So it actually creates 2 more. Let's zoom in one more time. So there's once and then twice. So that one's gonna have 2 right there. And they may not all be, just because they cross it doesn't mean that they're relative extremas, but they have to change from positive to negative or negative to positive. And in this case, it changes. It goes from negative down below here to positive above, and then it goes from positive above to negative. So it all changes sign. So I'm going to go ahead and resume that. Okay. So in that spot where it looks like it bounces, it actually doesn't bounce. It actually hits it twice. So I'm going to go ahead and go back from my original. So that's 1, 2 right there. 3 because it goes from negative to positive. 4 because it goes from positive to negative. And then 5 goes from negative to positive. And 6, it goes from positive to negative. So this one, it's going to hit it 6 times. Okay, and 87 should be E. So let's look really quickly. 87, the answer should and is E. Okay. 88, graph of a twice differential function is shown above, which of the following is true, right? So it might take you a moment to look through this, but these are all f prime. So f prime, f prime, f prime, right? And it's just saying that for this function here, so let's look at this function, right? F prime means the derivative or the slope at -1. So at -1, the slope is actually 0. So let's write this down, right? So f prime of -1 is actually, in this function, is actually 0. It's flat. Okay. F prime at 0 right here, that I don't know what it is, but it's actually going up, so it's a positive. And at 1, okay, that's going down. So f prime at 1, I don't know what it is, but it's going down, so it's a negative. So if I'm looking at all these answers here, okay, this one would not be a good candidate for a test or quiz question because it relies on the following, right? It says which of the following is true. So it relies on you having access to answers A, B, C, or D, right? So it's not A because, right, f of -1, right? So it's saying that this is the smallest, which is true, right? So if I put that there, let's see, negative, and then f of, oh, sorry, wrong one, f of -1, f of -1 is 0 right there. So this is saying 0 is smaller than f of 1, then a negative, which is smaller than positive, okay, which is false. Okay, these two are definitely true. Negative is smaller than positive, but 0 is not smaller than negative. So that right there comes out to be not true. Okay, B, so f of -1, which is 0. So they're saying 0. So saying 0 is smaller than f prime of 0, which is positive. So 0 is smaller than positive, which is true. And then smaller than f prime of 1, which is negative. Okay, so this part is true. That's not a problem, but this part is not true. So we're not going to use that as well. That cannot be it. C, f prime of 0 is positive. Okay, this is already false, right? The positive cannot be the smallest value because it's now it's saying that these are bigger than the positive. So we already know that is not true. That's not going to be true. Okay. F prime of 1, which is negative, right? So this one's saying the negative is smaller than f prime of -1. F prime -1 is 0. So negative is smaller than 0. That's true. And then that's smaller than f prime is 0, which is positive. This one looks like it's going to be true. Positive is bigger than 0, and 0 is bigger than negative. So I'm going to have to go with this one. Okay. And we can double check the last one really quick. I'll do that in orange. Okay. So this says f prime of 1, f prime of 1 in this case is negative, so negative is the smallest. F prime of 0 is positive, which is true. Okay, zero, a negative is smaller than positive. Okay, but and then it's saying that the positive is smaller than f prime of negative 1. F prime negative 1 is 0, so it's saying positive is smaller than 0. That's not true, so this one is not it either. So 88 should be D. Oh, missed it again. Keep missing that. 88. Yep, that's D. 89. What is the volume of solid generated by the region bounded by this and the lines x equals 0, y equals 5, and revolve around the y-axis, right? So if you kind of want to redo this, we haven't revolved around the y-axis before. We've revolved around the x-axis. The y-axis is this one. X-axis is this one. We've actually just only be revolving around the x-axis. Okay, spinning it. But y-axis is the same thing. You're just gonna make sure everything is in the opposite or the inverted function. And this one is, look, if you look at the function, it says x equals square root of y minus 2. So it's already in the function um, x equals. Now, if you kind of want to see what it looks like, okay, you can graph that, or you can't graph it like that. You can do it on Desmos, but you can solve that by squaring it. So this will be x squared equals y minus 2 because I square both sides. That's going to get rid of the square and the radical. And then I can add 2. So my function, if I really want to see what that looks like, it's going to be x squared plus 2 is equal to y, which is actually going to be this function, which is actually going to be this function that looks like this. X squared plus 2 is going to look like that. All right. And we want to revolve it from 0. Well, let's see. And the lines, oh, x equals 0, which is going to be this line here. And y equals 5, which is, that's 1, 2. So it'd be something up here. Okay, so we either can, so they want this region right here or this region. And they're both the same. Right? You can see that it's the same. So we'll just say this region right here. And we want this right here revolve around the y-axis, which is this one right here. Okay, so nothing special. It's right up against the y-axis. And remember, the area or the volume is going to equal the integral from a to b of the area. Okay, so a to b is going to be from right here from number 2 to number 5. Okay, because that's where the region is. Right, and remember, we're going along the y-axis. We're using the equation x equals. So we're going to go ahead and it's not going to be from A to B like that. Okay, it's going to be from A to B like that. So it's going to be integral from 2 to 5. Give me a second. So from 2 to 5. And the area is going to be a cylinder or a disc. Okay, so it's going to be the area of that, which is going to be pi. And then the radius is going to be from here to here. And remember, normally our radius is going to be from the x-axis up, right? And we usually measure like that. Okay, but in this case, we're measuring it along the y-axis, so it's going to be from the y-axis to the right, just like how we do it from the x-axis up to the top of the function. Okay, and that's when we have a dx in regards to the if we're rotating it, revolving it around the x-axis, right? Well, in this case, it's going to be a dy. Oops, I should probably have that dy. Okay, so your function is going to be just this right here, square root of y minus 2 quantity squared. And this is the cool part. The square and the square root is actually going to cancel out, which just leaves you with just y minus 2. So in your calculator, So once you have all that realized, this is actually a very good one. A very good test question one. Because it doesn't rely on any of the questions as well. You're going to go ahead and do your finite integral. Okay, I know it's all in terms of y, but you can just write it, type as an x. So that's going to be the function y minus 2, and I'm just going to type it in as x minus 2. Okay, comma x. Okay, it's really a y, but it's fine. Comma 2, comma 5. And that's pretty much it. And I do need the pi in there, so because it's pi times all that. So I'm going to insert it in at the beginning. So if you don't know how to do it, you have to retype it, but pi times finite integral, all that good stuff. And looks like it's 14.137. Okay, looks like answer is going to be E in this case. Okay, if you need to rewatch this, okay, rewind it, or you guys don't rewind. Um, skip back to a previous section, but 89 should be E. So 89, answer should be E, and that does match up. Number 90. Okay, this one I looked at it a little a little while ago, and this one I have no idea. When I do come up with it, I will let you know. Or if you come up with it, be nice if you can share. But this video is a little too long already. I'm not gonna share with what my thoughts are. It's just, I don't think this one's gonna be worth my time or your time. Only number that you may have is just the 12 years, right? I'm thinking you're gonna have to come up with a function for p, for the population, which may be p e equals, whatever it is, your amount, then 1 plus, right, or whatever it is, or actually this is exponential growth, so we might have to do the rate, and then times some weird crazy stuff. But yeah, number 90, I'd say save your time because it's only one problem. Take a guess. Number 90, answer should be A. Okay, 91. Function is continuous, and this integral, so this one, it does give you an integral with a function u, right? Function evaluated at u, and it does tell you it's equal to 6. So if you do happen to somehow get this right here, you do know that it's going to be equal to 6, right? And you're going to have to find the value of this right here. So if you notice, all of this right here, um, it looks like it's an integral also, but the function is not a function with a u in there, right? This is a function not with a u. So I'm thinking if you let the u equal all of that, then you would sort of make it match. So I'm going to try to go in that route. Okay, so I'm going to say we're going to let, okay, you don't have to say let, but we're going to let u equal x squared minus 1. So that way du would equal 2x dx. So now we're going to change everything from variable x to variable u, right? And if you notice, we do have an x dx right here, x dx. So if we rewrite this, and we also, oh, and we got to get rid of that 2, so we can rewrite this and say 1/2 du is equal to x dx. Right, so we can make that happen right there. Right, so right here, we're going to go ahead and do this as integral. So the f of the x squared minus 1 and the x dx from 1 to 3, like that. Right, and notice that this x squared minus 1 is the same as u. So f of x squared minus 1, we're going to rewrite that as just f of u, which actually matches that over here. Pretty cool, huh? And then that x dx, the x dx, that's right here. It's actually going to be 1/2. So I'm actually just going to write it as 1/2. I'm going to write the 1/2 up here, and then du back here. And now everything's in terms of u. And look, you have the 1/2 du, and look, you already have the f of u, right here, right? And then this is going to be integral, all that stuff. And here's the cool part. Wait for it. When when we have it like this, the 1, or the 1 right here, the 1 is an x value because these are all in terms of x. So 1 is x, and if we put the 1 right here, we put the 1 right here, it'd be 1 squared minus 1. Okay? So 1 minus 1 is actually 0. So u would be 1 minus 1, which means u would be 0. Meaning instead of x equals 1, u would be 0. That's the cool part. And then if we go ahead and we let x equal 3 right here, right? That's the 3. So when x is 3 and we let the x equal 3 right here, 3 squared is 9. 9 minus 1 is 8, which means u would equal 8. So instead of 3 for the x, it'll be u would equal 8. And if you look at it, all that matches it right here. All of this right here is what we have here, and that's equal to 6. So we don't have to do any of that. That is just equal to a big fat 6. Okay. So all that is 6, and then we have times 1/2, which should be 3. So our answer is B, which is 3. I thought that was pretty cool. I would have never thought of that in my whole life. But, oh, that was number 91, should be B. Pretty cool, huh? 92 should be A. And as I'm looking at 92, let's see. This one is I looked at it in a little while ago, and this one it's that's a lot of ambiguous things. Only thing I can get out from here, and I'm not gonna spend too much time. If I have to, I'm just gonna make an educated guess. But closed interval from A to B, right? Meaning that on the x-axis, if you start with A and you end up at B, okay, that means it's defined for all of that. That means that there should be a point everywhere between. So there'll be a point here, point here. Basically, it should be like connected from A to B. So it could look like that. It could look like this, all connected, right? So basically a solid line, and even the endpoints are connected, right? So it could be anything. Um, but it says that it's not continuous from A to B. Right? Well, for me, I'm thinking it should be continuous because if it's closed, then that means that it's continuous, right? But it does say, okay, a little part does say that it does not attain a maximum value on A to B. So that means that it can't actually do that, or it can't actually do that. It doesn't have a maximum value. Now, if it's continuous like that and it doesn't it doesn't attain a maximum value, then that means between A and B, it means that there must be some kind of a vertical asymptote to where your function is defined like, hey, it starts here and then kind of goes up, 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 and then keeps going up there, and then it just kind of continues here, right? And then may do that or something like that. Okay, so it may be something like that. Um, it's not continuous. I mean, which of the following must be true? I mean, not sure about any of those. So I'd say this one, just take a guess, but it's a little iffy. I mean, we don't even know what bounded means, right? Bounded means that it's surrounded by a function. Like, what does that mean? F does not attain a minimum. So if it's kind of like this, then what? There'd be no minimum. Like, there'd be no minimum. Well, that keeps going down. So, but well, if we have this, then that means that at this point right here, C, right here, that means that there's no value and it's not defined, right? Or it's infinity, but does that mean defined? So, not sure. I mean, then that means that it's not continuous. So there's a lot of different things that can go wrong, and I'm just not really quite sure and um, not very super sure about this. But this one 92, so you can think about that if you like. But I would actually save my 3 minutes or 2.9 minutes and save for another problem that I can have more confidence in it. But that was A right there. That means that it's not continuous. Okay, so so that's the part where I'm a little iffy on, because if it's defined, right, if the function is defined, then that means that there should be a point everywhere, and that means that it should be continuous. But If there's an asymptote, then that means that domain doesn't involve it, which means that it may not be continuous. And that was obviously the answer. So, okay, take it with a grain of salt. Right. Good luck on your quiz test Friday.